Good morning, my dear friends. In the last class, I was explaining you about the integration method of determining the coordinates of centroid for any geometric section. Now, in today's class, I'm going to explain you about centroid or center of gravity for plane figures. So, generally, we see sections like T section, L section, and I section. So, which are nothing but plane geometric sections, right? They have only areas, but they doesn't have any mass. The center of gravity of such figures is found out in the same way as that of the solid bodies. The center of the area of such figures is also known as centroid, and it coincides with the center of gravity of the figure. It is a common practice to use center of gravity for centroid and vice versa for plane geometric sections. So generally, if I consider any plane section, an irregular body which is lying in the first quadrant, right, where we can see x-axis and y-axis, reference x-axis and reference y-axis. Now it has got a centroid capital C whose coordinates are x bar and y bar. As you all know that x bar and y bar are the distances from reference y-axis. X bar is the distance from reference y-axis and y bar is the distance from reference x-axis. Now in order to find out x bar and y bar, what I'm going to do here is just I'm going to divide this entire section into number of parts. In this case I'm just dividing this thing into 9 number of parts. So each of the part, for example, I'm considering the first one. The first part, it has its own center, or you can also call that one as centroid. I'm taking that one as C1 whose coordinates are x1 and y1. In a similar manner, I'll take C2 whose coordinates are x2 and y2. Similarly, if there are n number of sections, then we will take Cn whose coordinates are xn and yn, where xn and yn represent the center or centroid of an nth element from reference y-axis as well as reference x-axis. Now the formula to find out the coordinates of centroid x bar as well as y bar. Now here x bar is given as sigma ai xi by sigma ai, and y bar is given as sigma ai yi by sigma ai. Now expanding the formula, x bar, which is equal to a1 x1 plus a2 x2 plus a3 x3 plus so on up to an xn divided by a1 plus a2 plus a3 plus so on up to an. Similarly, y bar refers to a1 y1 plus a2 y2 plus a3 y3 plus so on up to an yn divided by a1 plus a2 plus a3 plus so on up to an. Here a1, a2, a3 and so on up to an, they refer to areas of the divided or the elements of a plane figure. And we have x1, y1, x2, y2, x3, y3. So all these things, they are nothing but the centers of the areas a1, a2 and so on up to an.